So what does it take really to have a safe and effective stereotactic QA program? After all, delivering just a few fractions at high dose rates can be daunting. Precision and accuracy in QA are of the utmost concern as you care for your patients. So choosing products that provide the highest precision and accuracy for your QA obviously need to be chosen carefully. Stereotactic goals to keep in mind as you're looking for your QA and putting together your program include positional accuracy, dose accuracy, and validation of imaging, planning, and treatment systems. So stereotactic programs really don't typically start with treating multiple metastases in the brain, but with larger tumors in other organs, and very often that is starting with lung. So our SI solution to get you started with an SBRT QA include our stereotactic dose verification phantom. It includes a QA slab and also is shown here with lung equivalent material. We also include a respiratory gating platform, a simplified platform that independently controls the range of motion and respiratory cycle. A Winston-Lutz pointer is, of course, key to QA of any stereotactic treatment setup. The Supermax electrometer is a powerful and very reliable device that you will use with a variety of detectors in a stereotactic program. No solution, of course, can be called complete without those detectors, as I mentioned. And two of the very best detectors for verifying your small field delivery are the W2 scintillator, shown here on the left, with our Max SD, and the X-Radon A26 micropoint chamber. The W2 is the next version, current version of our original W1 scintillator, both of which, of course, can be used and are widely used in the field. The W2 upgrade has upgrade to a 1x1 millimeter fiber, and it has a KQ of 1. So does our W1. They both have a KQ of 1. Which make them the premier measurement detector for the smallest of small fields. The X-Radon A26 is made entirely of low-Z materials, which makes it the only reference class micropoint chamber on the market without the wonky effects of other micropoint chambers currently available. Using the A26 with its predictable response curve makes small field measurements as easy as using a farmer chamber in larger fields. Now back to the SDVP, or Stereotactic Dose Verification Phantom, for a moment. It is very versatile and compact, being only 20 by 20 cm. As seen here, there are at least 4 standard configurations. I have seen others in clinical use. There are embedded fiducials in the top and bottom here that are configured to be nonlinear and non-coplanar to create an isocentric volume. Our ion chamber plug with gold fiducials, as shown here, is very useful for tracking, it's for fiducial markers for tracking smaller, localization of smaller tumors. The QA slab that you can see here, and was seen on the previous slides, is a great spot check of CT densities, air, water, adipose fat, trabecular, and cortical bone. It also includes high-density target and avoidance structures to test the TPS reconstruction capabilities. The Stereotactic Dose Verification Phantom heterogeneity lung inserts, as I showed you here, facilitate Monte Carlo type calculations, something that is otherwise only found in much more expensive phantoms. Now on to our Lucy 3D QA Phantom. The Lucy Phantom is a gold standard used for end-to-end testing of the entire stereotactic treatment chain. The precision manufacturing of this phantom allows users to verify cumulative uncertainties of the treatment chain to within 0.1 millimeter accuracy. This is accomplished by using a variety of inserts with precisely known volumes, geometries, and distances for accurate measurement. We work with each customer to tailor the best Lucy package for your department's particular needs. The Lucy is uniquely designed to lock the Phantom and inserts in place to facilitate reproducible setup and measurement to these very tight tolerances. Lucy is put through the same processes as an actual patient, which means that the Phantom will be scanned on CT and/or MRI to start the treatment chain. It is therefore very important to perform a variety of QA tests on those imaging systems. For CT image QA, we have marker cylinders, we have a couple of irregular volume inserts, a CT density insert, and a distortion grid. The CT densities are, again, a great spot check for the range, since it includes air, water, adipose fat, trabecular, and cortical bone. CT scan tests may include various scan thicknesses to find the optimal thickness for SRS imaging, spacing, distortion, and phantom orientation. MR inserts include matching marker cylinders filled with mineral oil, matching irregular volumes, again filled with mineral oil, an MR signal generator, and we also have an MR distortion grid. The isocentric irregular volume insert here is used for both CT and MR. The marker cylinders for CT and MR have known distances of 5 millimeters center BB to center BB and are placed in the Phantom precisely 60 millimeters center cylinder to center cylinder. The irregular volume inserts are also known volumes and recorded in the user manual. CT and MR inserts are used to perform image fusion and verify accuracy of multimodality fusion, CT to CT, CT to MR. You also verify object reconstruction, comparing scanned object volume against the known volumes, and verify position accuracy of objects, such as centroids and the fiducial markers or BBs, and also for distance measurements. It is worth noting that we use irregular volumes instead of just circles or spheres, as this is the quickest way to see any issues in image fusion. After all, an arc on a circle is an arc on a circle. You can also easily use the irregular volume inserts for some basic auto-contouring or deformable registration tests. Simply rotate the Lucy sphere with one of our regular volume inserts in it to create a new shape, again, of a known volume, which you can test against. For treatment plan system QA, you can test the following: manual versus auto segmentation, contoured volume versus standard volumes, or versus DVH isodose volumes, dose models such as Monte Carlo, conventional, or pencil beam, and you can test TPS limitations for small fields and accessory and couch modeling. The left plan here was a delivery of 4 conformal arcs on an isocentric target. Notice our irregular isocentric volume insert used there. And on the right, you've got a plan that was created using the largest target in our irregular volume insert. Verification of the treatment is done using film and micropoint ion chamber or other small field detectors. Note that our detector insert is 1 cm thick, and therefore the detector you use needs to have an outer diameter of less than 1 cm. So again, our X-Rated A26 and our W2 scintillator are both ideal solutions for point measurements. One of the unique aspects of our Phantom is that we lock the detector in place so that you never have to worry about an air gap or chamber displacement. The centroid of the collecting volume will be locked at the geometric center of the Lucy Phantom, no matter the orientation. The Lucy 3D volumetric target dosimetry kit is really kind of my favorite out of the Lucy accessories. It includes our multi-met insert here on the left, a multiple film stack here on the right. You can use up to 13 films for tumor volume type studies, or again, to be placed across the midpoint of the multi-met's targets. And the center here is our target and avoidance structure insert, where the black is high contrast bone rod against a blue water equivalent material, which means that it images extremely well. The C-shaped target and this target are extremely hard targets for the treatment planning system to recreate. So they are fantastic for testing your contouring volume accuracy, image transfer accuracy, and the limitation of your dose algorithms. You can therefore go through the entire workflow with these inserts as a great end-to-end test. Here we have an image of the C-shaped target planned for delivery, which is then verified with film and/or micropoint detector. The multi-mets insert has 4 targets in nonlinear, non-coplanar arrangement as well. These 4 plus the hidden target insert, which is provided with the Lucy Phantom, gives you 5 targets for planning and treatment. In this case, we show a plan with 2 targets using the multi-mets insert. The planned versus measured QA results were found to have a pass rate at the 2% 2 millimeter of over 99%, and the dose agreement was greater than 98%. Other end-to-end tests with Lucy include the hidden target test using the insert with the center fiducial. Use it to plan, scan, treat, and verify process QA checking position, tolerance to under 1 millimeter, dose tolerance to under 2%, and dose distribution, tolerance is 2% 2 millimeter, and you're running an over 95% agreement. Mechanical accuracy is tested with the Winston-Lutz pointer as well, which is attached to the same base as the Lucy sphere is attached to for other QA. And of course, we offer our PIPS Pro Stereotactic module to automate those Winston-Lutz tests that you perform as part of your Stereotactic QA program. To summarize, whether you use Lucy on its standard precision base locked to the couch bar, or you lock the Phantom or the pointer into the coordinate system with an interface, or you ensure that the centroid of your detector's collecting volume is indeed at isocenter, you can be confident that you are performing your stereotactic end-to-end QA with the best precision and accuracy. Now, I have focused the greatest part of this presentation on the hardware side of the standard imaging solution, but it probably leaves you wondering a bit more about patient QA beyond ion chamber and film. Again, a few fractions delivered in high dose rates requires rigorous QA. So let me just mention our patient QA solutions that provide you the most pertinent information automatically for your team to make treatment decisions. Firstly, Adaptivo, which includes pre-treatment, in vivo, and adaptive modules. Adaptivo gives you full insight into your patient's treatment at each fraction, improving your ability to adapt plans as needed. The software not only automates pre-treatment and exit dose delivery verification, but also uses daily CBCT to provide automatic, daily, and cumulative 3D dose comparisons to intended dose. LinAcView is Standard Imaging's log file-based patient QA solution. An overview of the workflow is shown here. An approved plan is exported to both the LinAc, including Elekta's MR-Linac Unity and LinAcView. Once LinAcView has received the RT plan, the log files that are generated from each day's delivery of the plan will automatically be brought into LinAcView, associated with the original RT plan, and analyzed. Not only does LinAgView provide pass alert fail results before the patient leaves the table, it also provides a wealth of information to investigate, understand, and address any issues with the patient treatment that you may have been alerted to.